Continental drift theory. Continental drift theory. Proposed by Alfred Wegener in 1912. 250 million years ago, all of the continents were combined into one supercontinent called Pangaea. The continents gradually drifted apart to where they are today, puzzle pieces. Continents look like they could be part of a giant jigsaw puzzle. Distribution of fossils. Plant and animal fossils found on the coastlines of different continents. Ancient climates. Tropical plant remains, coal deposits, found in Antarctica. Glaciation in Africa, South America, India, and Australia during the same time. Sequence of rocks. Same rock patterns found in South America, India, Africa, Antarctica, and Australia. Problems with the theory. Theory was not accepted by scientists. Why? Because Wegener could not identify the cause of continental drift. Causes of plate tectonics/drifting. Convection currents. Hot magma in the earth moves toward the surface, cools, then sinks again. Creates convection currents beneath the plates that cause the plates to move. Heat transfer, the driving force of plate tectonics. Theory of plate tectonics. Plate boundaries. Causes of plate tectonics. Plate tectonics. What is plate tectonics? The Earth's crust and upper mantle are broken into sections called plates. Plates move around on top of the mantle like rafts. What is the lithosphere? The crust and part of the upper mantle equals lithosphere. 100 kilometers thick. Less dense than the material below it, so it floats. What is the asthenosphere? The plasticity layer below the lithosphere equals asthenosphere. The plates of the lithosphere float on the asthenosphere. Two types of plates. Ocean plates, plates below the oceans. Continental plates, plates below the continents. Plate boundaries. Divergent boundaries. Boundary between two plates that are moving apart or rifting. Rifting causes seafloor spreading. Divergent boundaries create mid-ocean ridges, rift valleys, fissure volcanoes. Convergent boundaries. Boundaries between two plates that are colliding. There are three types. Type 1, ocean plate colliding with a less dense continental plate. Subduction zone, where the more dense plate slides under the less dense plate. Volcanoes occur at subduction zones. Andes Mountains, South America. Type 2, ocean plate colliding with another ocean plate. The more dense plate slides under the less dense plate, creating a subduction zone called a trench. Aleutian Islands, Alaska. Type 3, a continental plate colliding with another continental plate. Have collision zones. A place where folded and thrust faulted mountains form. Transform fault boundaries. Boundary between two plates that are sliding past each other. Earthquakes along faults. Another example of a transform boundary is the San Andreas Fault. San Andreas Fault, California. Seafloor spreading. Introduction. Tube worms live in the Pacific Ocean about 1 mile deep near the hydrothermal vents. Mapping the mid-ocean ridge. The East Pacific Rise has a mid-ocean ridge. Curves around like a baseball. Lies hidden under hundreds of meters of water. Sonar. A device that bounces sound waves off underwater objects and then records the echoes of these sound waves. Sonar mapped mid-ocean ridges. Harry Hess, an American geologist who studied mid-ocean ridges. He suggested that the ocean floors move like conveyor belts, carrying the continents along with them. At the mid-ocean ridge, molten material rises from the mantle and erupts. The molten material then spreads out, pushing older rock to both sides of the ridge. As the molten material cools, it forms a strip of solid rock in the center of the ridge. Then more molten material flows into the crack. Seafloor spreading. The process that continually adds new material to the ocean floor. Evidence: molten material, magnetic stripes, and drilling samples. Evidence. Magnetic stripes. How does the pattern of matching stripes show evidence of seafloor spreading?